Hello and welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with AWS located in Europe. I'm going to be your host for this session. This is the first in our Journey Through the Cloud series webinars for 2015, and today we're going to be taking a look at running development and test workloads on AWS. The Journey Through the Cloud series is a series of webinars that's supported by Intel. And in this series of webinars, we're taking a look at a variety of different AWS services and how you can apply these different AWS services to particular use cases or usage scenarios that you might have within your organization. So we're starting with dev and test today. And if you check out the campaign page for these webinars, which you can find in the notes if you're watching this on YouTube, or in the links panel in the webinar interface, you'll be able to find the rest of the series for 2015. And in fact, you can already register for the rest of the webinars that are scheduled for the rest of the year. So I'd like to encourage you to do that. Just a couple of other points of housekeeping before we get started. Elsewhere in the webinar interface, if you're watching live, you can see a files panel. In that files panel, you can download a PDF of the materials from the session today. So I'd like to encourage you to do that, mainly because there are links embedded in many of the slides, as usual, that we're going to use today. And it's that much easier for you to access the references that we're using if you just click on the links in the PDF rather than having to copy the URLs into your browser. So please do download the materials and you can refer back to the materials and, of course, access those links much more simply that way. The other thing that you should be able to see in your webinar interface is a Q&A panel, and I'd really like to encourage you to submit any questions that you might have during the session today if you're watching live. I'll be on hand to answer those if I can during the session, and of course, as usual, if there's any questions that we cannot answer during the session today, you can expect to follow up on those in just a few days from myself or a member of our solutions architecture team here at Amazon Web Services. We'll come back to you with answers to your questions, including further references and reading that you might want to take a look at to explore those answers in a little bit more detail. At the very end of the session today, you'll see the webinar interface change. We'll do a bit of live Q&A. Should have time for that after the session today. And you'll also then have an opportunity to rate today's webinar, give us a score from 1 to 5. We'd love to get some feedback from you. Much of what we do here at Amazon Web Services is directed by customer feedback, and that includes our webinars. So it's good to know from you what we're doing well, and more importantly, maybe, what we can improve upon and make better for future customers that might attend this series in the future. So please let us have your feedback by scoring us. And if you've got any feedback during the session today, things that you feel we should cover, please submit those in the form of a question and we'll try and cover them at the end of the session. The final thing that you will see at the end of the session, actually you can see on the screen now, social media links. So there's my Twitter on the screen there. At the end of the session, we'll show you some social media links for AWS official accounts that you can use to stay up to date with new Amazon Web Services services, events, other webinars, customer case studies, how-to guides, and other information that will just help you build your knowledge of how you can get value out of using the AWS cloud. So stick around and please follow the social media accounts that you'll see at the end of the session today. So we're done on housekeeping. Let's get going with the content. The Journey Through the Cloud webinar series, what we're looking at here really are common use cases and adoption models for the AWS cloud, orientated around a particular set of challenges or use case scenarios that you might see within your organization, aiming to share some good practice that's been developed by other customers adopting AWS over time, so learn from the journeys that other customers have taken. And we'll hopefully help you discover those best practices so that you can use those yourselves to bootstrap your own projects and make them more successful. Okay, so those are 3 things we cover in this series. Jumping into the specific topic that we're going to cover today, which is obviously development and test on AWS. I thought it'd be helpful, first of all, just to talk about why customers tend to start using AWS with development and test workloads, because that's a definite pattern that we see when we're looking at the way in which customers adopt the AWS cloud. Many customers start with dev and test. And there's a few reasons for that. The first is that you're exploring the benefits of the AWS cloud with what is quite obviously a non-production use case. So you can familiarize yourself with the benefits of using AWS, the way the tooling, the interfaces, the SDK, the CLIs work. And you can create agility in your development and test projects whilst learning how the AWS cloud works. That's the first sort of area of benefit that customers get out of using AWS for these kind of workloads. And secondly, the elasticity and automation that AWS offers. And actually, these are things that differentiate AWS really. Those provide real advantages in the context of dev and test workloads, and we'll illustrate that to you as we go into a little bit more detail through the session today. The agenda that we have for you today. First of all, we're going to take a look at why you might run development and test workloads on AWS and just expand a little bit on what we've talked about there at a very high level on that prior slide. We'll then talk in detail about AWS Services that you can use to support dev and test workloads. We'll talk briefly about developing and testing commercially packaged business applications on AWS, and then we'll go and have a look at some common development and test architectural patterns. And lastly, we'll just show you a couple of quick resources that you can use to learn more about running development and test workloads on the AWS cloud. And obviously at the end, we'll have some time for Q&A and answer with a few of the questions that you are hopefully going to submit during the session today. So why AWS for development and test workloads? And answering that question, it's worthwhile just focusing on a couple of the common traits of development and test infrastructure. The fact that you're quite often working with projects that are short-term in nature and lead to the creation of infrastructure which often needs to be disposed of when your project has scaled down or even completely concluded. And secondly, there are benefits in having numerous development and test environments and having the capability, the opportunity maybe, to parallelize some of the activities that you do when you're working on software development and testing projects. So we'll focus on the first of those, which is this disposable characteristic. And you're working here quite often with projects that stop and start frequently, as I've just said, projects that require infrastructure for relatively short periods of time. But you still want the ability to recreate environments in a known state or maybe in a prior state that you might previously have configured or set up. And the use of golden masters is a very, very common technique there, snapshotting environments and storing them for future reference or future reuse. All characteristics that are well supported by some of the services and tools that AWS provides. And on the other half of the equation, when you're thinking about the numerous nature of these environments, where you need many of them to support application development and testing cycles, you may want to preserve known configurations across numerous different environments, and as I've said earlier, be able to restore or roll back to a particular configuration from a specific point in time. And you may have overlapping development cycles. Say, hypothetically, you might be working on introducing an entirely new version of your software product, whilst at the same time having a separate or the same development team working on bug fixes or minor version enhancements. Those cycles can frequently overlap. You may need two or more environments in order to allow you to do that in an unconstrained way. And the cloud is a really good fit for that. In fact, it's a really good fit for both things, dealing with the disposable nature of these environments and also dealing with the fact that they are sometimes numerous in number. So the actual characteristics that enable this, there's four kind of broad areas really where the AWS cloud is valuable in this context. The first is in this idea of infrastructure as code, where you want to deploy to a known state quickly. The second is the ability to have access to what's effectively unlimited elastic capacity. So you can take large amounts of capacity when you need it. And the flip side of that, of course, is that you can throw it away when you don't need it as a result of the on-demand charging model that AWS provides. And then lastly, providing for durable storage, the ability to preserve environments or artifacts for future reference and reuse at another point in your application's lifecycle. So how do specific AWS services map into those four themes? What we're talking about here really are tools that you can use to create and manage an elastic data center to support these development and test workloads. A combination of EC2 and the Amazon Virtual Private Cloud. This is our elastic compute cloud, by the way, the virtual machines that you run inside AWS that can support your Windows, Linux, or other x86 workloads. And the VPC, it's a mechanism for creating your own network topology, your own set of controls, for example, routing tables, security groups, network access control lists, restricting which traffic can go where inside your networking environment and connecting that back to on-premises infrastructure if you need to do so. And using EC2 and VPC, essentially providing a set of building blocks there that you can use to create and manage this elastic data center construct. Second service that you can see here is Elastic Beanstalk, a managed standard application container service, which we'll touch upon more in a second. And then lastly on this slide, CloudFormation, enabling you to declaratively define AWS environments which comprise potentially complex collections of AWS services, and to control those via a templating language. So just expanding a little bit there. EC2 and VPC, we're talking about armies, Amazon machine images. Those are the base images from which you would start instances. Snapshots and bootstrapping. And this allows you to use these core AWS features to customize and set up an environment to meet your needs using either the console or through scripting. Elastic Beanstalk, with those managed standard application containers, is giving developers access to development and test environments directly from within their IDEs or directly from within CI/CD tools, and enabling developers to configure containers that meet their needs through a simple set of properties. And we'll expand on that more in a few minutes. And then with CloudFormation, this idea of declaratively defining environments, you're taking full control, as I said earlier, of what can be very complex collections of AWS services. And you can build and version control those environment specifications at the same time as you build software, either as part of a development and test process or as part of a continuous integration, continuous deployment workflow. We'll touch upon an example of a customer that's doing the latter later in the session today. So first of all, let's take a look at Army snapshots and bootstrapping in a little bit more detail. And what we're talking about here is using the Amazon EC2, the Elastic Compute Cloud service, and a feature called the Army, the Amazon machine image, which is the generic image that you start with when you come to create an EC2 instance. You will select your Army from either a collection provided by AWS, a collection which you might have created and customized, which you can see at the end of this process here, or from third-party sources like those that might have been shared publicly or those that might be available in the AWS marketplace, something that we're going to talk about much more later in the session today. You can take that baseline Army, you can create an instance from that. You can customize that by changing configuration settings, loading on software that you might need, and then you can refreeze that, snapshotting that EC2 instance and creating a derivative Army from the first one, which is stored and available within your account for future reuse. And this allows you to create these reusable golden images, which can be the customized building block for your application deployment or used as part of your development and test workflow. It's a very powerful feature that many AWS customers make use of if they're using EC2. Combining that with the VPC that we touched upon briefly a few minutes ago, this idea of having a customized networking environment that you can use to extend your on-premises environment with a large amount of additional resources for the period that you need them. You can forge a secure connection from your on-premises environment to the Amazon VPC using either a VPN, so that's a standard IPsec VPN, or using another service called Direct Connect, which is a 1 or 10 gigabit high-speed, low-latency connection between your networking environment, so that's either your data center or point of presence on your network, and the Amazon VPC that you can construct. And that gives you a secure, high-speed connection between your users on your own premises and that collection of resources inside Amazon Web Services that you can make use of while you need it. And of course, you can discard that when it's no longer required, and you will stop paying for the compute resources at that point. So that's a very powerful tool for creating the elastic data center that allows your developers and testers access to the infrastructure resources that they require in order to execute projects on your organization's behalf. Move on and take a look at these managed standard application containers with AWS Elastic Beanstalk. And this allows you to create application environments and actually manage multiple versions of your application across those environments, maybe vary those environments according to what their usage scenario is going to be. And the packaging formats that are supported for your application are relatively varied. We support 7 different formats, so Java on Tomcat, PHP, .NET, Python, Node.js and Ruby. And earlier last year we also announced support for Docker containers within Elastic Beanstalk. And what this allows you to do in essence is to create all of the resources that are required for you to execute your application, your web application. So it might be elastic load balancing, auto-scaling groups, EC2 instances. Once these resources have been created, they'll then be controlled by the Elastic Beanstalk environment, and you can release versions of your application into that environment. The containers will be created or updated depending on whether you're doing a first deployment or an update, and different versions of your application will be made available via endpoints on your Elastic Load Balancer. Log files will be collected centrally, and as we've said earlier, you can manage different application versions in this environment. So it's a very, very simple way for developers to get access to the AWS resources that need to run versions of their application without actually having to worry about configuring those resources themselves. You can customize the environment, but it takes care of things like creating your ELBs, your Elastic Load Balancers, creating auto-scaling groups, creating your EC2 instances, even creating RDS databases if you need that for your application, giving you access to log files and other control data, and really taking away some of the complexity that might be inherent within doing that yourself. Elastic Beanstalk will take care of that for you. And then lastly, in this tooling for creating and managing the Elastic Data Center, AWS CloudFormation. It's a very, very powerful tool that enables you to define collections of AWS resources within this CloudFormation template. Those are executed by an engine, and the resources defined within the template will be built out. The characteristics of the template are quite interesting, actually. You've got a procedural definition of precisely what it is you're going to create, and it will give you a known configuration. Okay, you can store your stack configuration in a source control system, and the stack configuration, the CloudFormation templates, they are JSON notation text files, so they can be shared very easily. They can be version controlled just like any other piece of code, but they're not entirely static. They can be parameter driven, so you can pass parameters into CloudFormation at the point at which you execute a template, and those parameters will be inserted into your template and can be used to drive customization of the environment that your template is going to create. You can find out a lot more about this at aws.amazon.com/CloudFormation. We actually have another webinar series as well called the Masterclass webinar series, where we deep dive into specific AWS services, going beyond the basics to give advanced users much more detail about how the services work and what you can achieve with them. And actually the first one of those masterclass webinars for 2015 is going to focus on CloudFormation. So you'll get a follow-up email on that over the course of the next few weeks. Obviously, we'd love to see you join that session or watch that session on YouTube, learn a little bit more about CloudFormation. Going into a lot of detail is beyond the scope of this session today, but you can see here, forgive the very small text size, but an example template from CloudFormation. This template will create a resilient deployment of the WordPress content management blogging system. And if you want to check out what's in that template, visit the URL at the bottom of the screen. You can download it and you can see precisely how you can use CloudFormation to define collections of AWS resources, work with parameters, bootstrap instances, install software onto instances, and create the other AWS services that are required to deploy that resilient environment for that particular application. Maybe the best way actually to learn about CloudFormation is to take a look at some pre-existing templates that have been created by others, either modify or reuse those for your own purposes, and from there move on to start developing your own templates to allow you to support your own development and test workloads using CloudFormation. There are some additional tools, relatively new services that AWS has either just launched or has in preview at the moment. In preview, we have ECS. This is the EC2 container service. And if you're working with application deployments using Docker containers, you might be interested in ECS. It provides a high scalability container deployment and scheduling service that runs on top of EC2 instances. It's in preview at present. The preview is publicly available, and you can find out more about that at aws.amazon.com/ECS. But if you're packaging your applications up as Docker containers, this can be a good tool to help you deploy and manage those containers, both in the development and test process, but also in scale operations. And then secondly, we have the first in a new series of services, AWS Code Deploy. This is a reliable and scalable service for deploying application code across fleets of EC2 instances, enabling you to code, build, and test applications in a controlled way. This is a service that's generally available in a couple of regions, in the US, and you can find out a lot more about that at awsamazon.com/code deploy. We're going to follow that up in 2015 with 2 additional services, Code Commit and Code Pipeline, that will enable you to do source control management using AWS Services, and also to enact a build pipeline using an AWS service called AWS Code Pipeline. So they'll come in 2015. There's already some documentation available for those services on the AWS website, and also there are closed previews available there that you can sign up and be considered for admission to. So if you're interested in those other services, just take a look at awsamazon.com/codecommit or /code pipeline, and you can find out more detail about those. That's a quick tour of services that you can use to create an elastic data center to support development and test workloads on AWS. What about packaged business applications? Maybe you're running applications from Microsoft, Oracle, SAP, or IBM, and you're interested in doing development and testing work on those commercially packaged applications using the AWS cloud. Well, that's something that many customers do today. We have comprehensive resource centers for those 4 software vendors, those 4 ISVs, at awsamazon.com/ the name of the provider, so Microsoft, Oracle, SAP, or IBM. You can see the URLs there. You find details there about how you can install software from these providers in the AWS cloud, or use pre-configured images from the AWS marketplace, including products like SQL Server, SharePoint, and Exchange from Microsoft, HANA 1 from SAP, Oracle 11g, PeopleSoft from Oracle, and IBM DB2 and the IBM WebSphere family of products also. So you can find out more details on licensing terms, including details about license portability, if you check out the resource centers associated with those software vendors on the AWS website. Let's move on now and take a look at some common dev and test patterns that we see across a wide range of different customers that are using AWS for these kinds of workloads today. And the first is the creation of complete frameworks and environments for software development inside AWS. So counter to what you might expect, it's actually very common for customers to run the whole of their software development workflow inside the AWS cloud, not just using it for deployment of finished artifacts or for deployment of finished software, but also using it to support the software development process itself. Things like source control, where you might run a source control system on EC2 instances. You may integrate with GitHub or with the AWS Code Commit service that I talked about being due to launch very soon. May run project management applications inside the AWS cloud. May run CI and build servers on AWS. That's very common. And you may also now run developer workstations on AWS using the Amazon Workspaces service, which is a service to provide desktop environments running inside the AWS cloud. Very easy to provision, simple pricing model, and very well controlled, supporting features like multi-factor authentication and golden images for those workstations. So combining those 4 services together, you quite often see customers end up with this architectural pattern where they have a source code repository, a CI server, a project management server, working together in concert. The developers accessing those services, obviously to work on features or work on issues that might have been submitted via their project management system, building and committing those changes into a source code repo, and then using a CI server to build those, depositing artifacts from those builds into S3 for later deployment. This is a pattern that we see very commonly amongst customers. Many of the tools that you might use to create this kind of environment are available in the AWS Marketplace. And if you're not familiar with the AWS Marketplace, this is part of the AWS website where third-party ISVs can sell software products to AWS customers. When they provision those products, they provision them using AWS resources. So you can see a couple of examples here, and these are very illustrative of the sort of products that you can access via the marketplace, Jenkins and Redmine. And you can see that there are a variety of different EC2 instances available for you to deploy these software products onto. So for example, you could deploy, let's take a look, Redmine powered by Bitnami on a T2 medium instance. The EC2 usage charges would be 5.2 cents per hour in the US East region, and there would be no charge for the software component of that. There are many different useful tools in here that might make it easy for you to build the architectural pattern that I just showed you on that prior slide without having the overhead of configuring these software products yourselves. So it's well worth investigating if you're thinking about maybe testing or developing the kind of architecture that we talked about there to support your own development and test workloads. And what we see with customers that have evolved this is they'll often have a CI/CD system which is creating CloudFormation templates at the end of their build process. And those CloudFormation templates are used then to build and deploy versions of their application and corresponding versions of the AWS infrastructure that supports the application that they've built. So this is a very common evolution of that pattern where CloudFormation becomes the deployment tool that customers use to get their application versions from their build system out into production on another set of AWS resources, which are of course kept separate from the development support environment that we just described to you a second ago. So that's one set of patterns around building the tools to support software development activities inside the AWS cloud. There's a second set of patterns around testing, and this is a very interesting area in my view. There are things that you can do in the cloud with testing that are actually very difficult to do with traditional on-premises resources, and a few of those are illustrated here. Things like running scale-up and parallel unit and regression plans. So as part of your CI, maybe test-driven development process, you may want to run large-scale unit tests. Maybe you're going to do cross-compilation across a variety of different platforms. Maybe you're going to have derivative builds of your product with different feature sets in them. And you can parallelize the build and test activities for those scenarios using large farms of Amazon EC2 instances. So if you've got 50 versions of your software to ship, you can spin up 50 slave nodes to do 50 builds and 50 sets of unit tests concurrently, rather than having to serialize that over a much smaller set of infrastructure that you may have in-house. So that's a very interesting effect of using the cloud. Similarly, on load and performance testing, you can use Amazon EC2 instances from the spot market, which is a marketplace where we sell currently unused AWS EC2 capacity, often at a substantial discount. The price varies by the minute, and you then bid on capacity from that spot market. And if your bid is above the current market price, you'll be allocated capacity, which you can then make use of to run your application. So it's a mechanism for accessing compute resources at a very potentially at a very low cost. This can be integrated with things like load testing to run very large-scale load tests against application environments on demand. Similarly with security, you may want to do security testing. You may want to do that in a destructive way, and if you create a sandbox environment, you can do that aggressive security testing on a copy of your production or copy of your test environment, and when that's finished, you can just tear it down and throw it away, and the cost will be minimal in many cases, and there'll be very little requirement for you to do any remedial work to recover that. You can just destroy that environment when you finish your testing. So it's also useful in that scenario. And then lastly, on testing at scale, A/B testing, where you might run multiple A/B scenario tests with replicated stacks. And look at each one of these in turn, really. So parallel testing, there's only one thing to say about that, which is one instance for 100 hours costs the same as 100 instances for 1 hour. So it's cost neutral for you to run a large fleet of instances within AWS that will help you get your work done more quickly by parallelizing it. So there's absolutely no downside to doing that. We'd encourage all customers to make use of the compute resources that they need at any particular point in time. As long as you're cleaning up after yourself, the cost impact of that will be zero. A/B testing is another area where you can benefit from making use of AWS, and there's a couple of reasons for that. The first is it's just that much easier to have multiple parallel environments with the elastic capabilities that the AWS cloud offers. So you can create multiple copies of your stack, really, that enable you to have different versions of your application in production at the same time, relatively short periods of time if necessary. And you'll of course only pay for those additional resources while you're making use of them. Secondly, we have some features that are intended specifically to help A/B testing or help people implement A/B testing workloads. One of those is something called weighted round robin on the Amazon Route 53 DNS service. This was announced quite a while ago, actually, back in 2011, but it allows you to specify the different weights with which different DNS responses are returned to end users. So, for example, to direct 15% of your users to a different endpoint for your application or API, and enabling you to have 15% of your users having the B experience in your A/B test whilst keeping 85% on your existing application version, and obviously using good practice around logging to determine whether or not that delivers better outcomes for your users, maybe better performance for your application, maybe a higher degree of monetization if you're running a e-commerce or other monetized application. So definitely check out the details of that weighted round robin feature, which you can find in the product detail page for Amazon's Route 53 service. Another dimension to testing is, of course, load testing. I mentioned earlier the EC2 spot market as a mechanism for getting access to large farms of low-cost compute resources that you might use for this particular phase in your application's testing lifecycle. And that's very simple, really. You can just apply these large farms of compute resource to generate load for your application, simulated load for your application. So direct your large farm at your endpoint or at your homepage or at your API and establish what the results of that will be. And using the Amazon Web Services CloudWatch metrics service is a great way to determine the impact of load testing on your infrastructure, maybe your CPU utilization, the performance or loading on your disks in terms of I/O or queue depth is something that you're interested in. You can see these and actually a vast range of other metrics from within the CloudWatch metrics services as well. So combining a load application together with CloudWatch metrics is a good way to determine where the bottlenecks are within your infrastructure, within your application. Of course, work on optimizing those. And returning to the AWS marketplace for a second, you can find actually a pretty wide variety of different load testing tools inside the AWS marketplace, many of which are integrated with the EC2 spot market. So that again is something that it's well worth investigating. If you haven't done load testing previously, or if it's something that's a pain point for you, then jump onto the AWS marketplace, search for load testing. I found 42 results in a couple of minutes by doing that, and you can take a look at the descriptions for the products that are there and establish which do and do not support the spot market. There's just one case study which I found particularly interesting actually in the area of load testing, which is quite a sophisticated load testing use case, which was done by Activision prior to the launch of their title Call of Duty Modern Warfare 3. It's a few years ago now this service was launched, and in order to avoid some of the high profile pitfalls that have befallen very large franchise launches in the computer gaming segment of this type, Activision did a very, very large scale load simulation exercise using Amazon EC2. They simulated 2.4 million active players on the service prior to launch, and by doing that they were able to ensure that they were able to support the launch day volumes for the usage of their service, the activity on the title, and of course by doing that ensure that they had a successful launch and that their player base was happy with the launch experience that they were able to get from Activision. So that's a really good example of using Amazon EC2 to drive really significant volumes of traffic to a product and establish that that product is going to work successfully when it's made available to the public or to customers. So just returning to our 4 points of benefit, we talked a lot there about using lots of capacity when you need it in the context of testing. How about the idea of throwing capacity away or discarding capacity when you're not using it? And if you consider a development environment, this is a hypothetical development workload where our developers come in the office at around 8 a.m, switch on their PCs, go and get a cup of coffee, and by 9 they're productive on the system, becoming more productive through the day, maybe as that coffee takes effect. And then in the afternoon, bulk of them leaving around 5, some of them sticking around until between 7 and 8 p.m. to complete tasks. And for the rest of the day, the development environment is largely unutilized. You know, we've got a small amount of CPU load there as the systems just tick over, but they're not actively utilized. And there's a helpful feature of AWS that allows you to clean away unused capacity, or maybe create capacity that you're about to use and then clean it away at a later stage. And this is to use auto-scaling by schedule, which is a feature of the auto-scaling service on Amazon's EC2 service. And you can use this to create and destroy computing resources at particular times of the day. And with this hypothetical workload that you can see here, you can see that we're creating 3 instances to cater for our development activity. We're spinning them up at 8 in the morning and we're shutting them down at 2000 at night. Okay, that's yielding to us 46% savings in comparison to running that workload 24 hours a day around the clock. So there are definite cost savings at hand that can be taken if you intelligently stop and start resources when you're about to use them, and of course stop them when you no longer require them. Bear in mind, of course, that saving will be 100% at weekends. If that development team were not working Saturday and Sunday, we could completely take down that environment and save 100% of our cost over that period. So really encourage you to think about what your usage profile is. Maybe monitor that using CloudWatch logs or using CloudWatch metrics, and then take down the resources that you're not using when you don't need them. You save a lot of money by doing that. The other part of our benefits case was around durability and the use of infrastructure as code. And I just want to touch upon this very quickly because I want to allow plenty of time at the end of the session today for questions. So durable storage, this idea of preserving your environment, your artifacts for future reference and reuse. And we have a number of services that can help you do this. The first we've already touched upon, which is armies. You know, the collection, the catalog of Amazon machine images. You could create one of those for each iteration of an application, storing your system state in a set of armies. Those are automatically stored in S3 for you in a private S3 bucket that you can't actually see. You are charged for that, but you don't have to manage that. It's managed on your behalf by Amazon Web Services. And of course, once you've got those armies, you can then recreate systems from any of those armies at any point in time. Just make sure you've got a record of which army is associated with which version, and you're good to go. You can also snapshot disk images. So if you had, say, data volumes attached to your images at other mount points or under the drive letters, if you're using a Windows operating system, you can snapshot those volumes at any point in time to freeze a copy of your data set and attach it to instances when you need. These, once again, are stored in Amazon S3 in a private bucket, so you don't have to administer that, but they're stored there on S3 for you. Highly durable, 11 nines of durability, located in the region where you have the instances that you've snapshotted. And this is also a mechanism for porting data between production and development and test environments. So if you've got a large data set that you're working with in production, of course you can snapshot that, create a set of EBS volumes from those snapshots, and then you can reattach those new volumes or attach those new volumes to a new set of EC2 instances. So you might use that to give your applications or your developers access to data from the production environment, and to do that in a very non-disruptive and safe manner, in a common with the technique that you might use with a traditional enterprise storage array. If you ever used an enterprise storage array to support that use case, you can do exactly the same thing in Amazon Web Services using EC2 snapshots. And then lastly, templates. So this might be a good place to store S3, that is, might also be a good place for you to store infrastructure templates that you might have built using AWS CloudFormation. You can store those in S3 buckets, highly durable, and there's integration between CloudFormation and S3, so you can access CloudFormation templates from directly within S3 buckets from within CloudFormation and create your stacks through that mechanism. And of course, combining those three things together enables you to roll back and recreate an environment for any given application version, as long as you've stored appropriate artifacts for that application version using the techniques that we've described there in that very durable Amazon S3 storage. Okay, so that concludes the detailed content that we've got for you in today's session. Just to summarize what we've talked about, really the high-level message here is that the cloud makes software development and testing easy, much easier than it would be with traditional on-premises fixed resources. You can make significant savings by making use of the elastic nature of the AWS cloud and be stopping and starting environments as you need them, maybe running your integration or test jobs much more quickly, and therefore accelerating your project and getting your time to value down, as well as making cost savings in the process. We provide a unique set of tools to help you create and manage environments, things like CloudFormation, things like Elastic Beanstalk, things like Code Deploy, and the other upcoming services that will be associated with that, Code Commit and Code Pipeline. making it very easy for you to create and manage multiple environments within AWS, and once again accelerating your development projects as a result. And then lastly, it enables you to operate at a scale and speed beyond traditional infrastructure. Okay, let's take a look now at some resources that you can use to explore some of the topics that we've covered today in more detail. And there's actually only one resource today. It's very simple. We've got a Dev and Test on AWS Resource Center on the AWS website. You can find that at aws.amazon.com/dev-test. And I think maybe the most important, interesting thing that you'll find there is a selection of customer case studies about large organizations that have and are using AWS to enable them to boost the speed and agility at which they develop and deliver new software projects. I really would encourage you to check that out. You can also find that link in the links panel that you can see in the webinar interface right now, and we'll also put that link in the video description on the YouTube version of this video. So please visit us there and learn more about how customers are using AWS to support these kind of workloads today. Just a couple of other resources for you. The first is just to give you a pointer to our AWS training and certification offerings. We now have a comprehensive set of self-paced labs, a classroom-based training program, and associated certification program that goes with that. You can find out more details about all of those if you visit the URLs that you can see at the bottom of this slide. I really would encourage you particularly to check out the classroom-based training. There's some excellent offerings there, and we're constantly working to enhance and improve our training. So even if you've done one of those courses before, within the last, say, 2 to 3 years, you'll find they've been revised several times and they're kept up to date with the latest AWS offerings and services. So please check out the details of the training offerings that we have. And then it's coming up to AWS Summit series, taking place in London on April the 15th. We have our London Summit, London AWS Summit. Whether you're new to the cloud or you're an experienced user, you can learn a lot by visiting one of these AWS Summits around the world. It's a free one-day event designed to educate new customers about the AWS platform, offering existing customers information on things like architecture, best practices, and new services. We also have keynotes, featuring, in the case of London, Amazon CTO Werner Vogels will be delivering the keynote there, joined of course by several AWS customers on stage who will explain and explore how they're using AWS to enable them to do IT in a new and better way. So do come along and join us at the AWS Summit in London on the 15th of April. You can register and find much more information, including a complete sessions catalogue for all of the breakouts at awsamazon.com/summits/London. In a second, we'll take a few questions, but before we do that, I just want to share the social media details with you that I mentioned at the beginning of today's session. So if you want to stay up to date with AWS's webinar program here in the UK and Ireland, in fact in Europe in the English language, you can find us on Twitter at AWS_UKI. And we also share information there about AWS user groups around the UK and Ireland, which are really good resource for new and existing AWS users. And if you want to stay up to date with AWS globally, you can find us at AWS Cloud, also on Twitter, where you'll find up-to-the-minute information about the latest AWS service launches, case studies, how-to guides, and other useful information about the AWS Cloud. And of course, if you want to stay up to date with what I'm up to as an AWS evangelist here in Europe, you can find me on Twitter at Ian M with 4 M's. Okay, so that concludes everything that we have for you today in terms of content. I'd really like to thank you as usual for spending your time with us today and joining us for this session. We do appreciate you committing your time to learn a little bit more about Amazon Web Services. So I'd like to thank you for that. Let's take a few questions now. And of course, if you do have questions, please submit those via the Q&A panel. Thank you.